Okay, so what you are saying is that the arcs and the okay, so the arcs are the same. And what else?
The little lines on the sides.
Lines on the side. Same. Okay, so what does that mean?
Like the side with like the two lines equals the other side with 3 lines.
Okay. So they have the same angles and same sides. Okay. So can I rewrite this? Do you mind if I write this? Same angles, same sides. Does anybody dispute or disagree with that? We're good? I agree. So is this statement correct?
Yes. IRS. Wait, let me see. No.
What are you doing? Why are you pausing? You said yes really quick.
No.
Then Jillian agreed with you real quick.
I did not say yes. Did I say yes?
Now,
I lost my memory.
isn't this what this says?
No.
Same angles, same sides. So shouldn't the triangles be congruent then?
No, they're not the same.
Okay, what's not the same?
You have to get the IRS. It has to be IRS, so the same as I is the one that has like the most lines, so it's T.
Okay.
And then R is 2. Yeah.
So are we good now?
Yes.
Well, this is now not the same as this because I'm missing a word. This is incomplete. What word am I missing?
Congruent. Similar.
No, similarity has nothing to do with congruence.
What's that one special word you taught us last week?
Starts with a CO.
Coordinate.
No. Wrong CO.
Congruency.
Well, we already have congruency.
Corresponding.
Corresponding.
Oh, you are so smart.
Corresponding is a very important word that we're going to use very often. You should have already heard it or seen it often. Corresponding is the order in which these letters have to go in congruency. So one thing that you need to take away from this is you just can't be random. You can't just say they have the same lines and they have the same angles. You have to say the corresponding sides and corresponding angles are the same. Corresponding is the key word there to finish this up. Okay, so that's the first part. If I were to need to know something for a test, corresponding is an important word.
Yes, sir.
The last 2 days, you don't have to have all 3 sides and all 3 angles to prove that 2 triangles are congruent. What do you need? You need at least, for a majority of the cases, you need at least how many? So what are the 2 things?
Side and angle?
No, that won't give you a whole bunch. That'll give you hypotenuse. Okay, so hypotenuse and leg proves you have the same hypotenuse and the same leg. And actually, there's an angle in there, the 90-degree angle. This only works for right triangles. So you probably need to put right triangles. So what's something else?
Are we supposed to be writing?
No, you don't have to. No. You can use this to study for the test. What else? Which is side, side, side. That works.
A.
SAS.
AAA doesn't work. SSA and AAA
AAA does not work. And SSA, or what my geometry teacher told me,
ASS.
don't be an ass. So he told me
Hey,
3 decades ago. I've lived to that as much as possible. It doesn't work all the time.
But how did you remember that?
ASS,
No. I mean, like, why would you just remember that randomly?
because it's stuck in my brain for these 3 decades.
Good at chocolate.
I've been a geometry teacher for quite a while, and that's one thing that I've never forgotten is SSA or AAS. It doesn't work.
No one.
What else? AAA and SSA is not a shortcut. Now, here's one thing I will guarantee. This is something that I know will happen. And I've told you this before. I've made these predictions before. One of the answers on the exam is going to be SSA, and guess what?
It's
We're
wrong.
gonna click it.
Somebody's going to click it. I don't know who it's going to be, but somebody in here will click it. And it's wrong. It's the only one that can't work out of all those besides AA.
Somebody's gonna put SSA.
So,
So it's SSA and then AAA does not work out.
yes.
Wait.
So we've got
It's
2 more.
what?
AAS works. And the last one, ASA. So these 5 congruency shortcuts are going to be important. If these two prove these 2 triangles are congruent, then you will use either HL if it's a right triangle, side, 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 angle, side, angle, angle, side, or angle, side, angle. So I would definitely study that for an exam.
Wait, ASS doesn't work.
AAS. ASS does not work.
So it's not one in AAA.
Yes.
So that will only work.
AAA. So why?
Okay? So, corresponding and these shortcuts are very important. Now, today and tomorrow, we're going to look at similarity. We've already studied similarity, but today we're going to take it one step farther in being able to solve for different things that we need or to be able to prove 2 things are similar. So take a few seconds. There is a new set of notes. Okay. What does it mean for 2 triangles to be similar? It's not the same as congruency. Okay? Congruent is over here. Similarity is over here. So you shouldn't use the words together hardly at all. Okay? So what is the same? Okay, so let's add our new word in that. Not just angles.
Corresponding.
Corresponding angles are congruent. Yes. You can watch the video tonight. So corresponding angles are congruent, and their corresponding sides are proportional. Now, some of you had a problem with proportions when we were doing the trig part. Remember, proportions mean that those ratios are going to be the same.
It doesn't let me write all that in the box.
I intentionally locked that one for specifically you, not to be able
Or how would you do that?
to. Yes.
But then I would forget it.
He's joking.
It's call it being facetious.
He's so funny.
Sorry.
I can't even see through it. Oh my god.
Okay, so let's look at the ratios. Now, when I say corresponding size, I'm saying like AB, okay, the first two letters of ABC, AB compared to DE. Okay, they're in the same position. So what is AB over DE?
Maybe 10 divided by 15.
Okay, so you can't just write 10 over 15 though. You have to make sure it's reduced. So 10 over 15 reduced is
2 over 3.
2 over 3. Now,
Oh my gosh, why did you get like this?
AC over DS. AC over DS. Again, when I reduce it, it's 2 over 3. You gotta hit the backspace. Just to start. And then the last one. BC over EF. When it's reduced, again, is 2 over 3. So, I want you to notice how many angles there are also. I have 60 and 45. I have 60 and 45. Now, do I need them to give me this third angle? Why not? They always have to add up to be 180. So as long as I have two, I can always find the third. It's just something that's understood. So as long as I have two angles, okay, the sides will always be proportional. As long as I have two angles that are the same, the sides always will be proportional. So what that does is it kind of sets up an ability for us to have shortcuts in determining similarity. I don't need to see all three sides and all three angles to prove similarity. The same way I don't need all three sides and all three angles to prove congruency. So we're going to look at the three shortcuts. Okay? So the first shortcut. You good?
Yeah.
Is angle-angle similarity. Angle-angle similarity says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. And again, similarity has nothing to do with being the same. Okay, that just means that the triangles look alike. So if I have two angles, that's enough to show that the two triangles are similar. So let's look at a couple examples. Write whether AA similarity can be used to show that the pair of triangles are similar. So I currently have a 90-degree angle and 35, a 90-degree angle and 55. With the information I currently have, I don't have enough to prove angle-angle similarity. However, if this is 35 and this is 90, then what's this angle?
55.
Do I even need to find this angle here?
No.
Because how many angles do I need?
2.
2. Now, I know this is 35, but it's not really a big deal. As long as I see 55, as long as I see 90, then that's all I need to say that the triangles are similar by AA. Okay? And I really don't even need this statement. You can write it in there, but they have two sets of corresponding congruent angles. Saying this, similar by AA, is the same as saying they have two sets of corresponding congruent angles. they're the same. So this is like extra. I don't mind if you're extra. Some of you go the wrong avenue extra. So do the next one. Can I prove that these two triangles are similar or not similar?
Yeah.
So what am I going to be looking for? Okay, so what angles? I have 110, I have 110. That's one. I need one more set. Well, this is 30, this is 45. So I need to have this angle be 30. So this angle is 25. And this one down here is 40. So do I have two sets of corresponding congruent angles? Then they're not. Let me move that.
How do you know that's 40?
Because they always add up to be 180. Always. There's one thing that later on in life somebody says, what did you learn in geometry? I want you to say, Nuri. I don't want you to say nothing. Okay? Nuri promised me this. You'll say all three angles of a triangle always add up to be 180. Say it for me. What did you learn in geometry? Nuri, what did you learn in geometry? You can't do it for me? Come on, I didn't hear what you said.
George, say it. The life could be worse.
Johan, I'll ask you that question again next year, okay? Oh my. Wait to see what you say about algebra 2. Because I'm going to bring in the cell phone box.
Don't do that. I'm not even.
Bring in the cell phone box.
Literally, no one's off.
No one.
Who's on it?
Person in front of you, person behind you, you people up here.
Well, that's not me.
Okay.
Wait,
Give him a hard
go
time.
back. I didn't think I was too busy laughing.
Hey, here it is. All right. You can watch the video later. Hear yourself laughing on it. Now, example 3. Example 3. I don't have any measurements. However, I do have arcs. So angle A is the same as angle D. Angle B is the same as E. So do I have enough information to prove similarity? Yes. AA similarity. Again, the only thing I need to see is yes, AA similarity. Now, they have two sets of congruent corresponding angles. Again, that's the same as saying AA similarity. There's nothing to even be implied there. They are the same thing.
Why'd you put AA though?
Because what do you need? What is this called? What does AA stand for? Angle, angle. So to prove similarity, all I need is angle and angle. Two sets of corresponding congruent angles. Now, AA is the first one. The second one is SAS, side angle side. Now, again, this is not the same as side angle side congruency. This is side angle side similarity. So if the lengths of two sides of one triangle are proportional to lengths of two sides of another triangle, so they're not the same, they're proportional. And their included angles are congruent, then the triangles are similar. Okay. So on your paper, I want you to draw these two triangles, A, B, C, and D, E, F, and put in the following criteria. AB is 4, BC is 6, and the measure of angle B is 47.
CD?
This is what you should have. Hey, focus. You should be drawing this on your paper. Go on. I can see right over here for you if you don't want to get distracted.
Is that F at the bottom left or D at the bottom
Yeah,
left?
this is exactly what's on your screen.
Look at your screen there.
Look at slide 7.
I know, but is that on the left? I mean, is that F or E? It doesn't matter.
Your triangles don't have to look the same as mine as long as they're in the same order. Triangle ABC, triangle DEF. Now, to prove similarity here, I don't have enough angles. I only have one angle. I do have the sides though. Now, you're not going to be given this on a test. You're not going to be given this in an assignment. They're not going to specifically tell you where things are, like the ratios. You have to know that AB corresponds with DE. You write the triangles down in that order, that's what's corresponding. So what is AB over DE?
4 divided by 2 over 1.
4 over 2, or when it's reduced, 2 over 1. Now, when we're working with ratios, we want to keep those fractions. This means that AB is twice the size of DE. What is BC over EF? 6 over 3 or 2 over 1. So the question is, are these corresponding sides proportional? Are these numbers the same? Yes. Is the angle between, or what they say included, the same? What's that number?
Oh, you're talking about the angle?
That's what I said.
Oh, yeah.
Are these angles the same?
Yes.
So I can show that triangle ABC is similar to triangle DEF because of SAS similarity. This is the answer. This is the conclusion that you're looking for. So what I would do is on my notes, instead of filling all that out, I would just take a copy of that picture. That way it's done.
Are you sure you're not gonna
Okay, the third one is side, side, side similarity. So I have angle, angle, side, and side, side, side. If the lengths of all three sides of one triangle are proportional to the lengths of all three sides of the other triangle, then the triangles are similar.
Wait, I'm still stuck on the other one.
You're going to have to stop talking.
I'm going to talking.
If the lengths of three sides of one triangle are proportional to the lengths of three sides of another triangle, then the triangles are similar. So again, I want you to draw your next. Don't care. Care about your grade. That's it.
That was
fair.
good.
So we have to prove all three sides are proportional. So AB over DE. What is AB over DE? 6 over 9 or 2 over 3. Again, the triangles aren't going to be given to you on the test. You're going to have to be able to draw these triangles on your own and set up these proportions on your own. So BC over EF. Or 2 over 3. CA over FD. Or, so do I have enough to prove these two triangles are similar? Yes. Triangle ABC is similar to triangle DEF because of SSS similarity. So again, you're going to take a picture of this and add it into slide 9. Now, what I want you to do, I don't want you to do slide 10. I want you to do the two examples on slide 11 on your own. Are these similar or are they not? If they're not, then what are you missing? If they are, is it AA, SAS, or SSS? It's going to be one of those three things. Now,